Hello everyone. Today's class we are going to discuss about the catalyst and the catalysis. Okay. Now catalyst. Catalyst is a substance which is accelerate the rate of chemical reactions and themselves remain chemically and quantitatively unchanged. That means catalyst enhances the rate of reactions but itself does not changes either chemically or quantitatively. Okay, this substance is known as catalyst, and the process in which catalyst works is known as the catalysis. Okay. Now let us take an example of catalysis reaction. Suppose this 2 moles of KClO3 reacts, okay, in the heat, in presence of heat, we get the product of potassium chloride and 3 mole of oxygen. Now if this reaction happens without catalyst, then the temperature need is in the range of 653 to 873 Kelvin, and the reaction is little bit slow. But when we add a little amount of catalyst in that reactions, then the reactions need 473 to 633 Kelvin, and the reactions will be faster. This is the decrease in temperature, and the faster the reactions is carried out with the help of catalyst. That means this catalyst helps the reactions to be faster and with a less temperature. This is the effect of catalyst. Okay. Now next topic. Next topic is the what? Next topic is the promoters and poisons. Okay. Promoters and poisons. From the name we can say promoter, which promotes the reactions, poison which depromote, okay, or means which poisons the reactions. That means what? See, the substance which enhance the what? Enhance the activity of catalyst. Catalyst is known as promoters, which known as promoters. For example, if you say, for example, when in Haber process, okay, when in Haber process, let me write, okay, when in Haber process, Haber process, when in Haber process, when in Haber process N2 gas reacts with 2 moles of H2, 3 moles of H2 gas in presence of Fe, that means iron, which is a catalyst, and molybdenum is another solid which act as a promoter, we get easily 2 moles of ammonium gas. Here iron acts as a catalyst and molybdenum solid act as a promoter. Okay. Next, the substance which decrease the activity of catalyst is known as what? Poison. Okay, known as position. Next topic. Let me wrap. We'll discuss a little bit about the catalysis. Okay. Now, catalysis is broadly divided into two types. First one is the homogeneous catalysis, and second one is the heterogeneous catalysis. Okay. Homogeneous and heterogeneous catalysis. Homo means same, hetero means different. That means homogeneous catalysis means the reactant and the catalyst in the same phase. First point, or you can say definitions. Okay, the reactant and the catalyst in the same phase. Okay, but here the reactant and the catalyst in different phase. Let us take an example here. Simple example. Suppose example of homogeneous catalyst in which the reactant and the catalyst in the same phase. Suppose when sulfur dioxide gas reacts with O2 gas, okay, in presence of nitrous oxide gas. It produces two molecules of SO3. Now, if we see the reactant, that means this one and this one, sulfur dioxide and oxygens, both are in the gaseous state, and the nitrous oxide, which is acting as a catalyst, is also in the gaseous state. That's why I'm saying the reactant and the catalyst in the same phase, that is gaseous state. Okay. Let's take another example. Suppose this one, this one, suppose 2. Another example. When this one, acetic is not acetic acid. This one. Suppose when methyl acetate. When methyl acetate, which is in a liquid hydrolysis with water in presence of catalyst, that means HCl, which is another liquid, it produces CH3 COH plus CH2 3O. That means this one ethanoic acid and this one methanol. Okay, this one is the homogeneous catalysis. Now let us take example of heterogeneous catalysis. Suppose first example. First example is the when 2 moles of sulfur dioxide gas react with oxygen gas in presence of platinum solid catalyst, it produced 2 moles of SO3. Now, if you see here clearly, the reactant, that means this one, sulfur dioxide and oxygen, is in the gaseous state, but the platinum, which is the catalyst, in the solid state. That means difference in state. That's why difference in state. That's why these are heterogeneous catalysts. Okay. Let's take another example. When N2 gas react with hydrogen gas in presence of suppose iron and molybdenum, which is a Hayward process, hair solid, we get 2 moles of ammonia gas, which is another example of heterogeneous catalyst, because the reactant is in gaseous state and the catalyst is in solid state. It's different in states. Okay. Next topic is the mechanism of heterogeneous catalysis. Okay. Mechanism of heterogeneous catalysis means how the catalysis is occurring in the chemical reactions. Okay, or you can say how catalyst is helping or catalyst is involving without itself changing in chemically or quantitatively the reaction is carrying out. See the first step. First step, this one is the catalyst surface. You can say a catalyst molecule where catalyst surface having free valencies. So this one, these lines are the valencies where the reactant molecule or reactant atom can attach to form the chemical reaction. So this one A plus B is the reactant molecule. A plus B reactant molecule. When this reactant molecule adsorbs on the metal surface, it produces this type of molecule. That means A is a reactant, B is another reactant. These two reactants are adsorbed on the catalyst surface. Okay. After the adsorption of the reactant on the catalyst surface, obviously chemical reactions takes place. Chemical reactions means there may be forming of chemical bond or there may be breaking of chemical bond. Suppose we are taking for a schematic diagram, the bond between the A and B reactant is forming in this way. Occurrence of chemical reaction, suppose bond between A and B is forming. Suppose bond between A and B is formed, but remember this molecule is already attached with the catalyst surface, and this position is known as the intermediate. This position is known as the intermediate because it is in intermediate positions between the reactant and the product, isn't it? Next, after the adsorptions and chemical reactions between the reactant and the catalyst surface, obviously the catalyst will leave the product as the process known as desorptions of product. Desorptions means the product is separating out from the catalyst surface. That's why I'm written here is catalyst surface we get in separated from, and here is product. Remember this one, this catalyst, okay, this catalyst we get as it is as the previous one, That's why I'm said, or catalysis process says that the catalysis or the catalyst does not involve chemically or quantitatively in the chemical reactions, because after and before the reactions it remains same. Okay. The main points, that means how to write the statements of the mechanism, may be coming in your screen. Okay. Now we will discuss two important features of catalyst. Okay. First feature is the activity. Activity of catalyst depend on the mainly chemisorption. Remember, chemisorption means the chemical reactions between the catalyst and the reactant molecules. The chemical must be adsorbed reasonably strongly on the catalyst. This reasonably means the catalyst, the binding between the catalyst and the reactant molecule should be in that much strong that they can remove easily after the chemical reactions, or they can attach also easily, so that they can react easily. Okay. After the reactions, the molecule should be dissolved. No, dissolved means the catalyst and the product should be separate. That's why the chemical must get adsorbed reasonably strongly on the catalyst, but not so strongly. If it is bind so much strongly, then obviously the product will not separate. That's why the binding between the reactant and the catalyst should be that much stable or that much strong, so that they can leave the product easily, and the chemical reactions also should be taken easily. Okay. Here's an example of when H2 react with water in presence of platinum catalyst, it produced 2 molecules of water liquid. Okay. Now second feature is the selectivity. The selectivity of a catalyst is the ability to direct a chemical reactions to yield a particular product. That means a particular reagent with particular catalyst forms a particular product, not a randomly. Suppose let us take an example. When carbon monoxide and 3 moles of hydrogen react in presence of only nickel catalyst, it produced 1 mole of methane gas and water gas. The selectivity means only nickel catalyst with the help of these two reactants can form this type of product. No other catalyst or no other reagent with this type of reagent or catalyst form this type of product. Okay. Next topic is our shape selective catalyst. Okay. From the name we can assume shape. That means the catalysis should be based on the shape. Okay. Now see what is the definition or what is the meaning of shape selective catalysis. The catalytic reactions that depend on the pore structure of the catalyst and the size of the reactant and product. And the reactant and product and is known as the shape selective catalysis. Okay. Depending on the pore structure of the catalyst and the size of the reactant and product molecule, the reaction is carrying out. Okay. See how. One of the most important or well-known shape selective catalyst is the zeolite. Zeolite is the three-dimensional aluminosilicate framework. That means aluminum, oxygen, and silicon atoms are interlinked in a three-dimensional arrangement. Okay. Maximum zeolite are honeycomb-like structure. Okay, honeycomb-like structure. Now, how zeolite is using? Let us take an example. Zeolite are widely using in petrochemical cracking of hydrocarbon. As you know, in our fossil fuel, large number of hydrocarbon, that means long chain of hydrocarbon is cracking with the help of zeolite to produce different kinds of chemicals such as petrol, diesel, kerosene, wax, etc. Okay. One of the well-known example is ZSM5. Okay. ZSM5 is a zeolite. ZSM5 is a well-known zeolite which converts alcohol directly into gasoline. Gasoline is one kind of petrol, or you can say fuel. Okay.